But it's interesting that the torch is a bit what so it's interesting if you look at the stats, because I am sure all the metadata know that and it's interesting to look at the areas of interest. Although there's lots of good stuff in the background, well, my 70% and in fact, we got each house. That's no, we did some of the because I don't get it for it. This one's called the WRC.
Really, there's some ways no neighbours who can see, therefore you can pretty much.
All I can say is like to go up on the satellite, well, so.
You can hear that.
Just about hear it. There's no aerial on it. There's also no power on the PA stages, so it's not very loud.
No, in displays would give you the contrast. And these sort of
Let's better that way round.
I nearly wiped out the engine on with GPS sources. So, yeah, we bought all the real bottles. Because it's so cheap. I'm not sure of references. No, originally I wasn't. My original there were enough spares in there. No, even 682. Not even tried. RS6.
All my 16 still just been taken over.
Yeah, well, they're quite very nice. I'm not worried about it.
Then the manufacturing for that chip, they were 13
just like still availability from on
12.629.
RS space. I was desperate to buy didn't care about the price. I think it's only the red tyres left because of still not covering the
Sorry.
What's the first presentation?
Yeah, so it's a bit traffic. Awesome has arrived. Even drowned our side. Yes.
So we calibrate all the legs. 28 days. So all across the Wiltshire. It's almost just
It's
Sorry, you're
Yeah. Manufacturer 36 they make three different suppliers put that together.
Yes.
So that's when the back production of this.
Next one came out, I think someone just had them.
It's much more genuine.
The real biggest joke about popping up with the nail guys, it's 690. After 10, it's
Apparently I'm now in charge. It's just black GLP. Fiberglass, you get it in black. So, welcome to the first Crawley Roundtable for how many? 3 years? 3 years. I think we wrote a programme for 2020, but it didn't go anywhere. It's slightly modified this year. So, yes, welcome. Thanks to the Crawley Club for hosting us. I'm not sure how many Crawley Club members we've got here, but there's quite a lot. For those of you who don't know, who aren't Crawley Club members, they do not charge us for the use of this facility. Neither Dennis and I are members.
Don't we?
You don't know. So, if you have enjoyed your day and want it to happen again, please leave a contribution either in the pot there or the pot by the entrance. And if you haven't signed in, please sign in because we photograph that and basically break GDPR rules and stuff like that. Anyway, as I'm sure most of you know, there is a recent event that has resulted in the death of Her Majesty Queen Elizabeth II. We obviously had COVID, so I'd ask you to just reflect for a minute on what has passed. All the silent keys, the likes of G3GRO, who organised this thing for many, many years. So. Okay, good practice ready for tomorrow. If you're quick, you might actually get in the queue. There's fast trains from Gatwick. So, next thing. Construction contest. It's the same old names, isn't it? People who won it, Martlesham, people who won it, Brow. People who won in previous years. It's almost a question of sticking names in the hat, but no, I was a bit more scientific than that. The two of us have had a look through, and we come up with a winner and a second place and what we consider to be joint third. And I'm going to have to put my glasses on because I can't read what I've written. So for those who don't know, we've got 6 entries from 4 people, several transverters, a down converter, and a portable signal generator and a box with a display on it. We'll look. The contest is judged on appearance, novelty, complexity, and originality, and it's what I thought. So if you don't like it, you can beat me up afterwards. And Dennis has had a look over and agrees with what I said, so you can beat him up as well. So in joint third place, we have the 23 SEMS transverter by Jen, and the portable GPS signal source by Dave. One thing I like about Jen's thing is he's dressed his cables. Anybody who dresses the cables is good in my book. Right, and in second place, Chris's 122 gigs transverter. Very neatly put together, compact, complete. Can't really see inside it, so I don't know how well you actually. No, it's fine. But in first place, something I've never ever seen before. A path propagation information calculator, also by Chris G0FTZ.
Very good. Excellent device.
Excellent device. I have no idea what it does, but it's something I've never seen before. Yeah, we've got lots of transverters. Everybody's got transverters. Come on then, tell us what it is.
Every microwave frequency from 26 and up. It has all the ICU loss tables built into a lookup table. Input the data from your rig light, noise figure, RDS, path length, transmit power, antenna gains and receive gains, and then tell you the carrier, split the carrier.
So we have gone from a world where we all did our own PCBs to where we buy module blocks and just glue them all together.
And every project in my has an Arduino in it as well.
So there's software. So he ticks the software box. Not saying others didn't, but ticks the software box as well. Okay. Are we ready? Right. Seconds out, round one.
Right, Chris. Anybody doesn't know, this is Chris G0FTZ. Used to have a G8 called on.
CIU, Chris.
CIU. Blimey. And he's going to be talking about 30 terahertz.
And
Right, off you go.
Oh,
Oh, sorry, I've got that wrong. It's Colin first. Chris, sorry, I've got that wrong. It's Colin first. Yeah, okay. Off you go then.
I don't mind.
That was Andy.
Right,
That was Andy.
we've got my notes there. Yeah.
oh, yep. There you go.
I can't work without those. And we've got a trick, I think. For this.
You've got a clicker forward, backwards, and a laser pointer in the
Okay,
middle.
right.
And you are live on YouTube with now 9 viewers.
Oh, that's nice.
Can we all say hello to the 9 viewers?
Hello, viewers.
I think they're mostly bots.
Oh, that's the camera. They're going to get a picture of the back of my head most of the
Yeah.
time.
No, they're just seeing the PowerPoint. So
Where's the camera?
it's a horrible little webcam up there. Sorry, we weren't expecting this.
Oh, right.
You want to stand on the other side?
So
you
yeah.
face the.
No, it's just the PowerPoint on the video at the moment.
Is that better? Right, doesn't really matter where I am. Right, Langston SDR transceiver. First question's got to be, what is Langston? Over the last few years, there have been, from various manufacturers, wideband SDR type chips made available. Obviously, the primary market is cellular phones, data transmission, satellite links, things like that. But they're all pretty versatile. But the main problem is that they're not that easy for the home builder to use. Some of them are very complicated chips. Two of the main manufacturers, Analog Devices and Line Microsystems, both made development modules using those chips. Well, when I wrote this, at reasonable prices, although the prices have actually shot up in the last year quite dramatically. But Analog Devices and Line Microsystems both make development modules for these. Analog Devices make a thing based on the AD9363 chip, which they call the ADAM Pluto, which is quite nicely boxed and ready to go. This is actually, ADAM means Analog Devices Active Learning Module. So it's actually designed for selling to universities and schools and things to do experiments with. But it actually makes quite a nice full duplex transceiver. As standard, 300 to 3.5 gigs, I think. but there's a fairly easy hack you can do to it. Software hack, which will make it go from 70 megs to 6 gigahertz. And performance drops off a little bit, but it's still quite usable over that range. So it's quite a useful device. They have gone up in price, unfortunately. They were about £100, they're now about £200. But not much we can do to control that, I'm afraid.
Well, at least you can play with it.
These are still available. There's 150 still in stock when I looked the other day at Mouser Electronics. Yeah, the other option is the Lime Mini. I think I've got a picture of these two somewhere. If this works. Come on.
Point the computer.
No,
Is that not working?
It's not working. No.
I'll tell you what, I'll do it for you.
Next one should be a picture of the.
I'll make it work eventually.
Give it a thumb.
I'll tell you what, I'll turn it off and turn it back on again. No, it's not working. All right, hang on.
So that's a picture. That one's a picture of the. Yeah, that'll do. That's the two devices. There we go.
No,
I'm not in control of the pictures anymore. I need slideshow mode. I don't know.
it should be inside then, but
There we go. Right, there we go. So those are the two devices we're talking about. The Add-on Pluto, which I have got one of. The other one was the Lime Mini, made by Lime Microsystems, using their LMS 7002 chip. They made quite a range of, or several Lime devices, but that was the most economical at the time. Unfortunately, that one is now out of production because of the chip shortage. There is a version 2 coming out, but they are talking about prices of $399, which seems an awful lot of money for a fairly small board like that. So at the moment, probably the only real option is the Add-on Pluto. But in fact, that performs, RF-wise, that performs better anyway. Although, as Dave would agree, it's not quite as reliable on the interface side of things. But we can work around that. Both those offer receive and transmit capabilities over very large bandwidths. As I say, the Pluto will go up to 6 gigs now. And with a bit of persuading and use of harmonic mixing, it will actually go up to 24 gigs. You can get usable signals out of it at 24 and 10 gigs. Not very strong, not very sensitive receive, but it does work. We've had ways of using these before, things like SDR console, which there should be a picture of somewhere.
we'll get there by the end of the day.
Things like SDR console will actually talk to those chips, and it's quite effective when you're sitting at home in the shack in a nice, warm, comfortable area. But you've got to admit, something like that is not easy to use when you're out on a hilltop portable or you're in the middle of a contest trying to do things quickly. So although they work and it uses a laptop, it's not really ideal for some of the typical microwave operating that we've been doing. They can be complicated to learn and they're very confusing when you first look at them sometimes, although there's a lot of features there that are quite useful for home stations. So we decided, or I decided, to start thinking about using a very much simpler system, such as the Langston, which is another picture somewhere, which you've already seen on the bench anyway, something like that. The idea was to make it look a bit more like a real radio than some of the SDR projects. It's got a real tuning knob. These are quite good ones. These are nice and free running. It's got a real volume control, proper microphone sockets. There is a touch screen for operation, but the buttons have deliberately been kept very simple. Most of the modes have been, most of the options have been designed to be used by microwave. This was actually inspired by the Portsdown project from the BATC. Thank you, Dave. They produced the Portsdown, which is effectively a TV station in a box that you can carry around with you anywhere you like. In fact, a lot of the hardware is common to the Portsdown, and Dave has done some work, and you can actually have a combined unit which will do both. So you can have narrowband modes using Langston, touch of a button, you can go to Portsdown and start doing digital TV. So a lot of the parts are common between the two. We've been trying to keep them as common as possible. Say touchscreen with large buttons, so fairly easy to use. Rotary dial for tuning, everything into one box, make a complete rig. Some people say, why do we call it Langston? UK Microwave Group was considering producing an SDR project and calling it a Hailing in memory of Mike Waters' G3 JVL. He lived on Hailing Island, and there was a slide somewhere which I haven't got control of. Langston's on the way to Hailing Island, so basically Langston was an initial project on the way towards the Hailing, so it stayed as being Langston.
I'd like to point out where Portsdown is on that map as well.
Portsdown's just off to the left up there.
So we're gradually going south.
Well, we also have the RIDE project.
Oh, the ride is in the same area, yeah. So I thought I'd try and keep the same name in convention and pick
Bit better than Bogner.
That could be the next project. Right, so next slide is slide number 6, which should be a picture of all the parts needed. There we go. So to make a simple or a minimum system for a Langston, what you need is basically what's showing on this picture. We've got the add-on Pluto. That's what you get in the box when you buy it. You get a couple of little antennas, which are not much use for anything, but they're there for testing. I think they're supposed to be cellular band antennas, in fact, but they don't really match on any frequency, I don't think. But they're useful for a local test. A USB lead, a Raspberry Pi 4. All this work has been done on a 4 because it's probably the most powerful one available at the moment. It does get worked fairly hard when it's working on some of this. You need a USB interface here for some sound, which is one of these cheap devices. The Raspberry Pi can only output sound, it can't input sound. So the simplest way is to buy one of these little dongles for about £3. It'll give you audio in and out. I said it was trying not to be a computer, but we do still use a mouse. But the only bit of the mouse we use is the rotary wheel for tuning and the buttons for selecting the tuning steps. Don't actually use the mouse movement at all. That was just for simplicity, to find a nice simple rotary encoder that we could use to operate that. And you also need a touch screen display. That one's there is the little 4-inch one, which is the ones on that one there. So you can have a very tiny Langston if you want. Subsequently, we've got a 5-inch display which works quite well, and also the 7-inch. So you can pretty much now build one of any size you need, and the display's the same, it just gets bigger for the different sizes. This is the official Raspberry Pi screen. This is one by DF Robot, I think they call themselves. And this was Waveshare, was that the Waveshare 4-inch? I think it was. This is the 4-inch one from Waveshare. They're all touch screens. These two both interface through the normal display connector on the Raspberry Pi. The Waveshare doesn't, it uses all of the pins, so it's not quite so usable. It tends to use up a lot of the I/O that's then not available for use on anything else. Now you also need an SD card to put the software on. And basically that's it. That's all you need to make a simple Langston. As I said before, recommended module is probably the add-on Pluto nowadays, because that's about the only one you can get. It gives the best frequency range once you've done the frequency mod. It seems to give less sproggies and spurs than the Pluto, than the Line does, so it's reasonably clean. And as I said, the Line SDR is not available at the moment, so it's probably not a good choice unless you happen to have one, which a lot of the Portsdown systems did, which is one of the reasons for making this support it. There is a new SDR being talked about and supposedly going to be made available next month, called the Caribou Lite, which is a relatively low cost at the moment device that goes piggyback on a Raspberry Pi interface, and he's claiming to give very good performance at good price, and they're less than £100 for the basic one. So there is some hope that there will be some more hardware around soon that is reasonably priced. To actually get it going, you'll need access to a PC and a wired internet connection initially, just to prepare the software on the SD card and to install the software. Once it's done, you don't need it again. Everything will run standalone. All the instructions are found on the GitHub page, and there should be a slide there with the GitHub addresses on it somewhere. The github.com has got the main software on it. You can download from that the files you need to build, and it's also full build instructions, blatantly copied from the Portsdown ones, said Dave. Thank you very much. So it's a very similar process to Portsdown, but you basically download the operating system image, put it on the card, make a small change on the PC, then you plug the card into the Raspberry Pi, boot it up on the Raspberry Pi, connect that to the internet through the network connection, and connect into it from the PC, and then all the rest of the building is done actually on the Raspberry Pi, and leave it running for 20 minutes or whatever it is, and it will end up with a working system. Fingers crossed, hopefully. Obviously that gives you a very basic system. You end up with a mouse for tuning, which is not ideal, but it does work with a rotary dial to do the tuning of the frequency. The buttons move the frequency digit left or right, so you can select which digit you're actually tuning with the knob. So you can do fast tuning by moving it over to the megahertz or hundreds of kilohertz, whatever you want. Menu selection is all done through the front panel. I'll show you that a little bit closer in a minute. And so probably what else do I need to make a full system? Probably the first thing that people want to do is convert this into a proper tuning dial. Relatively easy to do. You either take an old mouse, there's plenty of them around, disconnect the rotary encoder in the middle of the mouse and connect in an external one. These are some fairly elaborate rotary controllers that I found on eBay. I don't think I've got a picture of them, but I can open up and show you. They're quite nice, 400 pulses per revolution, very smooth. Give a very nice spinnable tuning dial. But you can use a simple click-click rotary device. Anything really that gives you the A and B phase pulses, which nearly all rotary encoders do. So you can pretty much feed anything in, either by modifying a mouse, or there is on the wiki page, on the wiki page, there is a design there to use an Arduino and build your own encoder that works. Effectively, it replaces the mouse. So probably that's the first mod that most people want to do, is to make a decent tuning system. Having done that, you then end up with a transceiver that's going to work from 70 megs to 6 gigs. Output power with the basic Pluto is in the milliwatts range. It varies over the range, but from 1 to 10 milliwatts, something. Is that about right? Would you agree, Dave? Something about that? Yeah. Sort of in the 1 to 10 milliwatts, varying across the range. So not a lot of power, but there is power available there. Receiver on the Pluto is pretty good. I've actually looked at the spec, and it says that the noise figure is 2.5 dBs. So it's not too bad on its own. Obviously it can be improved with an external preamp, but it works surprisingly well. I've been surprised, just connecting an aerial straight into that. I can pick up beacons that I normally hear on the transverter fairly weakly, and they come through on the Pluto no problem at all. So sensitivity is actually pretty good on most bands. I think it probably falls off at the top end. But that's one fairly straightforward. So an amplifier, a power amplifier, a filter, and somewhere switching between them. Basically, on the Raspberry Pi, we do output. On this case, I've got eight bits that are available, which you can use to switch external relays for routing the signal. So you could have a secondary box with all the relays, amplifiers, preamps, whatever you like in it, and switch each one in as you went to each individual band. So that's all remotely switchable. BATC does make a PCB available for an 8-way RF switch. I think that's still available. Yeah. So you could use that PCB with a solid state switch to take the output of this and route it to 8 different amplifiers. And it'd be fairly easy to link in. So there's a bit of home construction to get a reasonable power, but as it stands, with a few milliwatts, might be enough to drive a transverter. You might be able to use it as your IF stage to drive another transverter, or for local testing. A few milliwatts to a decent aerial, you still get a reasonable distance. One thing you will need to do, if you're concerned about that sort of thing, is put some filtering on the output. The Pluto is basically a square wave output, so there is a lot of harmonics there. So on the wiki page we have got an example of that, showing it on 77. So there's every third harmonic is quite strong. So you will need filtering on the output for any sensible use. There is a way of doing that. If you just want to spend the money and you don't want to build anything, you can go for a thing called the Lime RFE, which is another slide for that somewhere. That's it. This is a thing also made by Lime Microsystems. I think they're still available. They certainly were a couple of weeks ago. They're quite expensive, so I don't think many people have bought them.
I don't think they're making it anymore.
No. This is quite a complicated device that Lime made as part of their system that they sold to universities, I think, really. That was the main reason for it. But that actually contains preamps, filters, power amps for all bands from HF to, get this right, it's for the Lime, so it only goes up to 4 gigs, I think. 3.44 gigs. So you've actually got filters, amplifiers, preamps, all bands from 0 to 4 gigs, about 1 watt out, 1 to 2 watts on all the bands. And there is a picture of the block diagram of it there, which is going to be meaningless, but it just shows it's a fairly complicated device. But it does actually work quite well. I've actually got one of those fitted in here. I can get about one watt on every band that it covers, up to 3.4. That's showing the more expensive version, which had cellular on it. But you can buy a version without the cellular bands, because we don't really need that. You can buy it with just the amateur bands on it. It's an expensive thing. I think it was about £450 last time I looked. Quite a lot of money. But there's quite a lot of components on it when you actually start looking at it. But there's nothing there that you can't build. A bit of experience in the room. I'm sure people can make amplifiers, preamps, filters without a problem. You might have to decide on 1 or 2 bands. It might not make sense to do all the bands, but it can be done. So, as somebody said just now, it's really a case of putting. What is that? It's really just a case of putting things together nowadays, not actually making anything. It's really more a case of assembling boxes. As a quick demo, I've got two and a bit systems here that I'm actually showing. This one is the 5-inch display. I've got the lid off if people want to come and have a look in a moment. This is the 5-inch display with a Lime SDR and the Lime RFE. So this is giving me an output range. This actually goes down to 4 meters. I haven't bothered to put HF on it, but it will do 4 meters through to 3.4 gigs at about 1 watt on all bands. What else got to say about that one? Not a lot. It's fairly compact inside. I don't know if I'm going to be able to show that. It'll be easy to come and look at it in a moment. But one thing I did find, and we have the Portsdown has had the same problem. The Raspberry Pi does generate quite a lot of RF interference. So a lot of the bits in here you can't see because they're all in screen boxes now. People are making things like the Lime are great for demonstrating on a workbench, but in practice, without a screening can, they don't work very well. They pick up all sorts. You've seen on here, there's a few sproggies around on that band that it's still picking up. They're weak, but they're there. For some reason, the Pluto seems better. I don't know if it's got a better screening or just better matching on what, I don't know. But a lot of the effort was put in filtering and getting some of the noise out of the receiver. There's also a 12 volt to 5 volt converter. Everything runs on 5 volts in the system, but it's nice to be able to run it on 12 volts when you're out portable. So there's a very simple switch mode converter. Again, it needed boxing up and filtering and goodness knows what to tame it down and get rid of the noise, which is always the problem nowadays. But basically that's one of the versions of it. This other one is my IC905 copy, in that it's a separate head and a separate RF unit. The Pluto is in fact a Linux PC in its own right. So if you plug a network adapter into the end of it, you can actually plug into it through Ethernet and talk to it over Ethernet, and that will work on the software as well. So what I've got here is I've got an Ethernet cable that runs between the two boxes. That can be as long as you like. I've had a 30-metre cable on it, it still works fine. I'm feeding 12 volts up the cable as PoE. It'd be nice to do 48, but at the moment I haven't got 48, so at the moment it's feeding 12 volts up, which is enough to run all the receivers in receive mode. It's not quite enough power to be able to run in transmit mode. So I've actually got a separate power connector for 12 volts for transmit, but in theory you could do what ICOM have done and run 48 volts up the cable and run this remotely. So I'll take the lid off. I've got to bring the screwdriver, but I'll have a look in a minute. Inside this one is the Adam Pluto. There's the Ethernet converter.
I'm beyond
The screwdriver anyway.
back there.
And I've used a couple of the small amplifier modules that you can get from eBay, designed for 2.4 gigs and 5 gigs Wi-Fi, and they'll give you about a watt output from a Pluto. So this box itself gives you about 1 watt on both bands. I couldn't find a cheap amplifier for 3.4, but in theory you could make it work on 3.4 if you can find a suitable amplifier, and I haven't done that yet. Basically up at the top is an Ethernet converter. There's a little box underneath that extracts the power, the PoE box. I actually built that myself, but again you can buy those commercially. There's the Pluto, there's some relay switching, some voltage converters. There's the 2 amplifier modules for the 2 bands, 5 gigs and 2.4 gigs. And there's some more relays, and finally the output. Works reasonably well. It's giving me about a watt on each band. And I did originally have a preamp in on the receive side, which was again a cheap Chinese wideband preamp, but it actually made the receive worse. I think the noise figure was probably worse than the Pluto on its own, which I say is actually quite reasonable. So in fact I've removed that, and so the receive is straight into the Pluto now. And sensitivity wise it compares very, very much same sort of receive as I'm getting from most G-Labs transverter on 2.3. Not a lot in it, might be a dB or so in it, it's very similar. So it's certainly quite usable on its own on those 2 bands, and it could be extended to other bands. You could make that as much as you like. So I did this before ICOM came out with their design, but I'm not claiming that they copied me. Basically in this box there's just the Raspberry Pi and the screen running, and nothing else in there at the moment. That's what I've got to say. Probably can't see it from the back, but everything's driven through the menus on the front. You can select the band here. It shows you what appear to be amateur bands. There's a choice of 12 different ones. There are in fact no bands on it, it's just wideband coverage for the whole thing. So all the buttons do is remember the last frequency you used on that button. And so they are currently set up for all the amateur bands, but they could equally be all set for the same band and just different frequencies on the same band. They can be set with transverter offsets, so you can actually have it reading out 10 gigs if you want. I think I've got 10368 on that one, which is adding a transverter offset. And it says transverter up at the top. You can set the offsets in the options menu, so you can display any frequency you like. I've got 47 on there. I haven't got a 47 gig transverter, but if I did have it, in theory it would work. Modes: upper sideband, lower sideband, CW, narrow CW, which is a quite tight filter, FM and AM. No real need for AM, but it covers airband, so you might as well listen to the aircraft anyway if it covers that frequency, so you can do that on it. I've got a built-in beacon mode, so you hit beacon and then hit dots, I'm going to put it on a sensible frequency first. Beacon and dots actually just sends out bip 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 on the. It's not me. Yeah. What's that? 271. I haven't got an aerial on this at the moment, so it's not very strong, but not very good. Not very good.
Do it the other way
Not
round.
the other way round. Yeah, that's right. There we go. Or you can do, if you don't want dots, you could do CWID, which again you can program in through the settings menu. Oh, it still says test Langston. Anyway, you can program that in under the settings menu. Going to beacon automatic switches to CW, puts in the offset, keys the radio, so you don't really have to mess around changing modes or anything. In the settings menu, you've got options for RF gain on transmit, so you can match the transverter drive levels, or you can match the amplifier drive levels with a preset gain for each band. You've got a preset receive and transmit offset for each band, so you can do all sorts of combinations for doing that. Quite a few people are using this on QO100 now. When you're in a split mode, you can actually receive at the same time as transmitting, so you can do full duplex. You can put in an offset for a 2.4 gig up converter, or you can use 2.4 gigs direct from the Pluto, which a lot of people are doing. You can put in an offset to compensate for your LNB local oscillator on receive, so that comes back on the right frequency. So we've built that option into it. What else have I done recently? As I say, you can program up the digital outputs to be any pattern you like on any of the bands. So depending on what relays you've connected and how you've connected them, you can pretty much set it up to do any switching you want. What other features have we got? The experimental feature is, although the basic unit only goes up to 6 gigs, you can actually use it to produce a usable signal on 10 gigahertz, and you can use it to produce a usable signal on 24 gigahertz. I was a bit surprised by that, but some of the TV guys found it before I did. The way the Pluto works is it's got effectively a square wave local oscillator feeding into a mixer, an IQ mixer arrangement. It seems like the mixer still works at the higher frequencies. So if you pick the 5th harmonic and you transmit at 2 gigs, the 5th harmonic is 10 gigs, it then modulates that 10 gigs with the IQ modulator, and you get perfectly formed signal out on 10 gigs. You don't get a multiplied times 5 signal, you actually appear to get a true fundamental. And I don't understand, I'm going to ask Andy about this because I don't totally understand what's happening, but you do. The same happens for 24 gigs.
Might be that you're only using odd harmonics.
It is only odd harmonics, and
Yeah.
only the 5th one. I was going to ask you that question, Andy, later on. If I use the 3rd harmonic, it's the tuning is reversed.
Well, there you are then. Yes. That's
Is that right? Is that what you'd
that's-
expect?
That's exactly what you'd expect. The 5th one correct.
The third harmonic works, but lower sideband becomes upper
If you think
sideband.
90 degrees, the 3rd harmonic of 90 degrees is 270, which is minus 90. And the
Yeah.
5th harmonic of 90 is 90 again.
Yeah, I
You've
thought of it
got
that
that
way, yes.
Yeah.
Well, that works then. That does work. So if you use the 5th harmonic on, say, 2 gigs, you produce a 10 gig output, and the modulation looks pretty good. In fact, it sounds pretty good. The level's pretty low. It's about minus 30 dBm at 10 gigs, and you have to filter out the 2 gig content. But if you do that with something like a pipe cap filter, and then put some gain after it, you can get a reasonable amount of transmit power on 10 gigs. Likewise, receive has probably got a noise figure of about 30 dBs. It's not very good, but stick enough gain in front and a bit of filtering, and it will receive 10 gigs. It will actually do 24, although I haven't measured the performance at 24, but it's going to be proportionally worse, I suspect. So it's quite interesting that it does work. It was found by the TV guys found it first of all, didn't they? Somebody found it, that it was working for wideband TV or digital TV.
So have you put that feature in your software?
Yes, there's a ×5 option in there.
What
It's
was the
set.
×3 option then?
I haven't put the ×3 in because it's reversed, and it wasn't.
Yeah,
And
but
it doesn't
you
give you any
easily
more.
reverse it.
You could.
Yeah.
It doesn't give you any more output power, so I didn't bother.
Oh, okay.
I looked, and in fact, the power output's almost the same, whichever one you use. So I didn't put, or did I? I can't remember, but it could easily be put in if I wanted to. Likewise, you can put it to double. There is an add-on that's a guy in, I think it was in Dubus, a guy in Austria? No, it wasn't Austria. Maybe it was Austria or Germany. Has developed a little add-on module that takes. It's got basically a doubler up to 10 gigs and then about 20 milliwatts, I think. And on receive, he uses a satellite LNB down converter down to 7.6 or 7.38 or whatever it is. Again, you can program that in if you want to, so it shows 10 gig frequency. But obviously that won't work on sideband because you are physically doubling the frequency then. And doubling on sideband produces just a horrible noise. It doesn't produce a usable signal. You can do it on FM. FM works fine. CW works, but sideband doesn't. So I think that's about it really at the moment. Any questions?
Can I add some comments? First of all, thanks to Colin for his work on the graphical display on the Raspberry Pi 4, because that one had beaten me and it enabled me to move the ports down to the Raspberry Pi 4. Lime SDR is not as good on receive as the Pluto. It's very, very noisy, like sort of 10 dB noise figure depending on where you put your finger near it. It's horrible. Pluto has some reliability issues, especially if you feed it with a high USB voltage. By high, I mean 5.1. If you give it 4.95, it is more reliable.
This is totally against what most people would normally say. They normally
Absolutely.
say,
And the line
make sure your
works-
voltages are right up.
The line works the other way, and it's unreliable on 4.95 and it's reliable on 5.1.
Since you said that, I actually turned the voltage down on this one, and it works much more reliable than it used to.
Yeah.
It would lose the connection occasionally for no apparent reason, and there's something in the Pluto that does that.
It's the Pluto disconnects from the USB bus at a stage during the boot process. I haven't got any further than that. But it connects for a moment, and then it decides.
But if you keep the voltage down below 5, it seems to work.
It's all right. I think the only other thing I'll do is a plug for BATC. If you do want a card for Langston, if you buy a BATC port standing card and put in the comments that you'd like Langston installed, I can do one for you. From the BATC shop.
But you have the install option in the port stand anyway, don't you?
You
Still?
do. If you've got a port stand, connect it to the internet and install Langston, and we'll install it. And you can then set it to boot to Langston if you want, or boot to port stand, or whichever you want. So, fair bit of integration. Thank you.
So, can I ask a question about the fifth harmonic mode? Does that support SSB operation?
Yes.
Yes. And if you load the port stand software, that's got a signal generator built in, and one of the outputs you can select is Pluto fifth harmonic, so you wind it up to 24048.1 and it'll be there for you.
I've actually used this as a test generator as well, because you've got in one of the menus you've got TX gain control, which has got about 80 dB of variation. So you can actually get some quite weak signals by using that. It makes quite a nice test source for some of the higher bands.
Yeah.
Try and build up this little mini one as well. We'll just push a bit together.
I've got a couple of questions.
What?
I can't get a 5
can't do anything with 3.
Standard 3 would be.
I think a 3 would be pushing. I'm not sure. To be honest, I've never really tried it in any depth. Dave might know better, but I don't think you can.
have tried it. I tried Pi 3 with a line, and it sort of worked, but it wasn't continuous audio.
Okay.
Yeah, although it looks like a fairly simple application, there's quite a high data rate going on
Because
between
it's
the.
using new radio
line
in the
and
background,
yeah.
which is
I'm using, what I haven't mentioned is the software. The actual radio side are using a thing called GNU Radio, which is publicly available. I actually wrote, if you look at the software source, you'll see the source code for that is available, and the GRC for that is available. So you can pull it up on a PC and actually look at the design for the radio. You can then, if you wanted to, you could go in and modify it so you have different filters, do whatever you like for the design. I then take that output file, which is a Python file, add a little bit to it to give it some remote control capabilities, and then I drive it with a separate program, which is the graphics interface. So the actual, I can't claim any, I can't claim anything for the actual RF side of things. Well, I designed the GRU, the GNU radio module, but I didn't design the modules. I just designed the layout.
GNU radio is quite low performance, really. So that's
It could be pushed. The Raspberry Pi is working quite hard in GNU radio, but by getting rid of the graphical side of it, which the Raspberry Pi is then not doing, it does improve it. So the only bit that's running is actually the RF bit of it, or the SDR part of it. If you try and run the graphics side of GNU radio on the Pi, it does really slow down, but I'm not doing that. As Dave said, I actually wrote my own graphics package. And we're not using any desktop on here. This is all running on bare hardware, so we're not using Linux desktop or anything. We just wanted to keep it as simple as possible. It's all running, it's running Linux, but it's running, what do they call it, headless Linux, I think they call it, or standalone Linux. It's not running the desktop package.
in the settings. Can you change some of the colours on the display? Because blue on black's not what I see.
Can you change the colours? You can change the gain. I don't think I can change the colours at the moment.
Oh, right.
It's not just blue. It does actually.
Oh, quite good out the back here.
It depends on the angle. It's very critical on viewing angle on this display. To be
Yeah,
honest.
and out in daylight. That's it.
You can set the FFT reference, so it does do a range of colours, but obviously the
Yeah, I
stronger it
was
gets, the
thinking
white.
more the rest of the game.
No, you can't at the moment, but it would be a 2-minute job to change the source code and do it. It wouldn't be difficult.
And then you can be even more like an icon. Colour scheme.
What about the bandwidth? Could you change the
You
display
can't
bandwidth?
easily change the bandwidth, and that's really down to the capabilities of the Pi.
Right.
We're running at close to what the maximum sample rate it can handle, and still perform all the background. This is plus or minus 50 kilohertz basically. It's running about 48 kilohertz sample rate. It will go up to 100, but you then start to get closer and closer to the 100% on the Pis, and they get hotter and hotter, and eventually they don't like it.
What about coming down to
You
2.5?
can come very narrow if you wanted to. I've not made that an option.
No,
to make.
I'm just thinking of the 705.
There is there was a branch of this that's, I think some guys in Holland did, where they took the basic code and they rewrote it to give a 500 meg bandwidth.
Right.
But in order to do that, they had, 500 kilohertz bandwidth. But in order to do that, they had to restrict some of the other features on it because it was then working exceedingly hard. This is running a Pi 4 at about 80%, I think, when it's running normally. Again, not the most efficient. If I was a good SDR programmer, I'm sure it could be improved.
Is it 4 gigs or 8 gigs RAM on the Pi?
It doesn't really matter, but it doesn't make,
Yeah,
it doesn't make a lot of difference.
It'll run on two.
It'll run on the 2 gig
Oh, right,
one.
yeah, the available Pis tend to be the small memory.
Yeah, it'll run on the small one. It doesn't use a massive amount of memory at all. It's very, very light on memory. So it'll run fine on the older ones and the smaller ones. There's quite a lot of settings on here. I'm trying to make them as simple as possible, but if you really want to run the Pluto remotely, there are 4 output pins on a Pluto GPO output pins. You can copy the band set bits from there to the Pluto. So in the case of this box, I'm actually switching the amplifiers via the Pluto. So when I set the band bits on here, they're actually duplicated on a header inside there, so you can switch. You've only got 4 pins, and one of those is used for PTT. So you've only really got 3 that you left for selecting the bands.
You could use them as SPI.
Yeah, you could program an SPI and program it if you wanted it to. Yes, you could do that. In fact, with this display, if you want to do anything very much other than have a display, you need an SPI adapter anyway, because this display uses up nearly all of the GPIO pins on the Raspberry Pi. But there is an SPIO expander that you can connect, and the software will support that. It will actually allow you to program another 16 IO pin if you want.
The frequency references are very simple, isn't it? And there's a mod
On a standard Pluto, it's not. I have replaced these with the higher spec TCXOs, yeah.
The usual one doesn't seem available until next year or something. Have you heard of any other options that are neat?
People put 10 meg external reference.
You can run it on pretty much any reference if you change the programming on it, yeah. There's a setting in the Pluto, you can set the reference frequency.
And the latest version of Pluto brings the
Yes.
reference input out to a
Yeah.
UFL.
On the early ones, you had to actually do a physical mod on the board, but you don't anymore. You can actually, you've got a connector on them now. Yeah, you can. The chip itself can be, and the software in the Pluto can run on any reference. So if you've got a good 10 meg reference, you could use that. I've never tried it, but you could.
So is that something you need to set in the settings?
No, that's all done in, well, because the Pluto is a computer in its own right. You'd actually do that on the Pluto, and the software here doesn't know anything about that. To be honest, it doesn't need that. All this does is ask the Pluto to go to a particular frequency. It's up to the
config file on Pluto.
yeah. There is a config file you can edit to change that. Having this as a standalone computer is one of the benefits, but it's also one of the drawbacks. In that you're trying to get 2 computers to talk to each other, and that's never easy. If one stops or one hiccups, you get a problem. So the line is more of a, it's not quite a dumb device, but it's a dumber device than this is. So it doesn't suffer from the dropouts and losses that this has. But this has proved fairly reliable now. Once Dave found the low voltage issue, which we still don't quite understand, but it does seem to work.
Listen to Xeno across it, is there? I've come across some Chinese boards where they stick a 5-volt Xeno across the wire.
No, there isn't. I don't think that's a Xeno. No, it goes through a series diode and then into a.
Just thought, I've seen them. It's a stupid thing to have done, but they did.
No, it goes through a series diode and then it goes into a switch mode converter. So first thing it does is convert down to 3.3 anyway. But I don't understand. That's why I don't understand why the 5 volts is critical. It doesn't quite make sense.
And I'm not sure whether it might be a Raspberry Pi artifact rather than a Pluto artifact. Don't know.
No, it does on the PC as well. I've had these drop out just as regularly,
okay.
just as regularly hooked up to a PC
Okay.
as I have on a Raspberry
that's
Pi.
interesting.
So I think that's unlikely.
A couple of comments from the internet.
Mhm.
John Power says hi from VK.
Well, VK.
Yeah.
Good to you.
John Woodman says hi from SV2. No question.
Right.
So, DX, microwave DX, VK, not bad.
So basically, with that size display and the Pluto, or one of the smaller devices, you could probably build a fairly small, not quite handheld, but fairly small rig that would be usable as an IF, certainly. Right.
What sort of power consumption is it?
Consumption. Oh, wow, good question. Well, I have measured it, I cannot remember. I think it's around about, because it's running the Raspberry Pi and everything, I think it's around about 10 watts. I think it's close to an amp
Yeah,
at 12
I was going to
volts.
say about an amp at 12 volts.
Yeah, 12 watts maybe. It's not super efficient, I admit, but most of that will be going in the Raspberry Pi. I think the Pluto takes about 200 milliamps at 5 volts. It's, again, not that low. Yeah, I think the whole thing was running on around about an amp, I think, most times. Obviously without amplified PAs and things, obviously that's extra. Right, okay.
Any more questions?
And once I have a look inside, we can open them up and have a look. Where's the time? We're due to finish it.
10 past 2.
How are we doing for time? Right, shall we have a break? And then Chris can do it. Yeah. All right,
I was asked to do this for the Martlesham and I declined, so you're
Oh,
very
right,
lucky
okay.
to get this.
Local knowledge.
You're very lucky to get this. I didn't really want to do it.
Well, thank you for your work on that. I'm really enjoying having mine.
I'm surprised how many people have built it, and how many people are actually, they're probably using it more than I am, to be honest. I'm more interested in getting it working than actually using it.
Yeah.
Quite a few people are using it. I've actually left the lid on, so you can't see it right here. It's all screened. But really needed to screen. I found it did. If you didn't screen it a bit, it just was too noisy. It'd get all over the place.
What's the little display inside?
That was my own little add-on, but it's not essential. When you buy the live RFD, it's not a flat box. It's interesting. What's going on? That was a little add-on that just brings out the settings and tells you
There's so many things about the Pluto being on the TV generating signals, but that's a number of queries.
Basically, it was something they designed for universities. They didn't want to spend money to teach I buy loads of these. Now, they're about 22 litres. Big enough to put a transmitter or something in it.
Feel the signal.
Oh yeah.
Of course, you realise that the signal
It's a good, yeah.
People have seen 10 kilometres so
Mine was more than 10.
that's the rotary encoder I got from eBay. It was about £10. I mean,
They're really good.
they're 400 pulses per rev. It's an optical glass disc encoder. That goes into Arduino, which is the A button now. This is the audio amp, that's the switch mode converter. So that's a 2 gig. It does run pretty hot. There's a little USB hub in there just to split it because there's not enough connections. The Raspberry Pi itself has actually got power over Ethernet, so if you feed 12 volts in on those two pins, it actually comes down the Ethernet cable. It's not intelligent power over Ethernet, which some of them are.
So here you've just got a PoE adapter.
There's a network adapter, normal USB network. And then I've made my own little PoE extractor that basically takes from the 2 minutes.
If you want anything, it has to be big.
With a voltage down converter.
Bigger is a cheaper.
Again, you can get proper, you can buy proper PoE.
Free for home.
Yeah. I'm hoping to be able to run the transmitter as well, but I couldn't get enough current to run these because they're a little bit hungry on current. One watt, 4 gigs and a 2 watt flash. Surprisingly, although they're made in China, they actually do give that sort of power out. They do actually give that sort of power out. About 10 quid each, I think. They weren't that expensive. Probably is, yeah.
On TV.
The Lime RFE was just something I thought I'd try and see, but it isn't expensive.
Really expensive, yeah.
There's a lot of chips on it when you start looking at it. The people kept asking, well, they were asking me and they were asking Dave for the board. Can we have a smaller display? Can we have a bigger display? And because we're driving the display directly, it's not quite so easy as just putting another display on. We've got to make sure that it's actually the right format. We could actually spray that box with paint on the inside, cut down on some of the radiation.
Where's your shirts?
That's that nickel spray paint, which seems to work quite well.
get stupid things like mafia.
Is that the head unit?
No, that's that bit.
Okay, so that's standalone.
That's a standalone system. That is it's working as an absolute minimum system.
COVID touch. This has got to be keeps it in storage too long, you get picked up with
Yes and no. No, you can use other ones. It's easier if you quick buy that.
Yeah, I thought, is it the CP106 or something?
It's down to what it identifies itself to Linux as. And because Linux is a bit fussy, in order to talk to that device, you have to know what it's called.
Yeah.
I have got a utility you can run that interrogates devices, finds out what the name is, and converts to software. So you can run it on other things. In fact, there is a headset you can buy that's got a USB on the end and plugs in. That will work. But it may not work out the box. What I'm saying is you might have to do some more work to get a different one to work. I found these for about £3.
And then
There's no guarantee what's in them is the same anyway. They might look the same, but they change the inners. You don't really know. Anything that's recognised by Linux as a sound device and supports 48 kHz should work. But its name might be different, so you might have to go in and change the software. There's an option to do that. Change the name so it finds the right device. Windows is quite clever. You just ask Windows for the first sound device, but Linux doesn't seem to want to do that.
It's the phase of the oscillator, of the local oscillator.
A little bit too flexible.
see that the whole
What is work? That's basically it's automation. So I can because you get the inverted side, so you get if you've got
That's what the guys in Holland did. They changed it all around. They said, I'm working that 500 kHz.
moving 3 times.
Yeah, it could be done. I couldn't do it that way. I don't like it that first.
I remember talking to him the line, and you lost it. And you see the.
I mean, it's all the software is there on the web. It's relatively simple. I'm not a great programmer, so
Yeah.
I'm going to change things. It's very easy. Some of it is pretty easy.
I mean, to be honest, I just joined the
Well, it's all like the same. Radio's to do most of the RF stuff.
Yes.
Single band one. On the card. Your band one works fine. Someone did that. You can put help driver on it. It's like bands on there, just 12 bands. Could actually have more and it basically changes the
With the original one, was far more complicated. Yeah, it used to generate
so you can have a different bit pattern transmitter.
It worked. The later ones
not the first one to ask.
What I'd recommend is see commercial receivers.
That's set up for SAPs, test SAPs, and it's actually doing 4 gig transmit, it's doing 730 something on receive download. So that would actually have sampling at 40.
The radar reflects that.
It would be nice to have it sampled more, and I am thinking about it, but it does push the
receivers. The original series of 1990 P&L chips, I mean, they're rubbish compared to that. That's why I always get them loads of different sorts. And I programmed it quite recently. Made an FM tuner. A local guy wants to do FM TV, so I'm sort of well, you say local, we did a link to 5.60. Then you get 5.60.
It's an interesting in some ways I was like hoping to sell transistors and the jigs. Alright, no worries. But honestly,
so I went out
the best place to sell stuff. You might yeah, so that's the FT tinkers. That's it, there's a shift. Some BFW
chips that's got 3 lines.
the old
BLW 96 put in AAA,
which are really obsolete. Even Italians are going through you just have to be patient. Or have hours of your life to spend on eBay. Yeah,
you are.
tell me about your car. Yeah.
It's bendy stuff, is it? Particularly low loss.
Yeah, it's very low loss stuff, but it's like being used in lab, thrown out, which maybe there's nothing wrong. Maybe it's If anything was slightly.
I've not come across anything this bendy before, right? So,
Yeah, so
that's what I was thinking. The one with the ends
it's
on.
just called a shower cable. It's just done as for protection. So
Okay, so it's just regular.
Yeah,
Okay.
it's a regular, normally I'm not going cable.
Yeah.
Okay, that's on the outside. So it's like you can walk over it without squashing it.
Yeah, that's clever. So it's not particularly anything more than RG213 in terms of
So
it does.
unfortunately, it's coming. It's not ready yet. So you just
It'll
have
be
to do your best.
They are. I don't know. They do very small microwaves for cables.
Yeah.
Yeah.
Okay.
But you did mention that.
It's
Yeah, this was in my Q100 edition.
So much crack that it doesn't work. Or does work sometimes.
Well, yeah, it would have been.
What are you looking for it? Alright, I'll tell you what, I'll take these two.
Sure, I'll worry you.
You've got a fiver. Handy.
Yeah.
I'll trade you a tenner for a fiver.
That one as well.
Sorry. I've got the opposite. Well, I've got the same problem as you've got.
Yeah, so if you go back to the last one,
I've got so
Carbon
many
dioxide
of these.
levels are very high.
Which is it more reliable?
It's bendy, I like it. It's not that bendy.
it's not tempting to do.
Ladies and gentlemen,
Take your places.
I've slapped myself on the wrist. We'd actually forgotten to present the winner of the construction competition to play the
G3
G4
G3
GRO, G3 GRO, Derek Hatter, a very good friend of mine at Hatter. And I'm passing it over to Stuart to actually present to Chris.
in dual role as CARC member and president of the RFC.
And a very good friend of G3 GRO for many years. So congratulations.
Well,
Thank you, Stuart. There you go, Chris.
Right,
All right, I'll put it back in the bag. I don't think you take it away, do you, this one?
Does that get engraved on plaques?
No, there isn't.
I don't know.
Okay. Right, I'd like to present Chris, G0FTZ, who's giving a talk on 30 terahertz. Something I've never played with, apart from standing in front of the sun and a bit of heat in the front of the heater. So over to you, Chris. Chris is a bit quietly spoken, so you may have to listen.
Apologies, guys. I'm not too well, so my voice is quite attenuated. So if you don't understand anything, please say so. I'm going to repeat it.
Yeah.
Right, 30 terahertz. Well, I'll give credit to this slide set was written by Barry, and I've modified it. With Barry, it's easy to read out, but not if you know it. Why is that? It's because, as far as I can tell, the electromagnetic waves.
Not working.
Oh well,
No.
it was
Didn't work
worth
for me
a
either.
try.
So I'm going to show you this afternoon how you could build a simple equipment and get on band and have a look yourself. Now, I originally came across this as a lockdown project for something to do. And virtually everything that you see here is built from eBay. Everything I ordered was from eBay. So it's very easy to get on band. Okay, next one please.
Oh, what are we doing there? Hang on, I shouldn't be doing that.
Slideshow mode.
No, we've got that one, haven't we?
Okay, where's the gap? Well, you can see here we've got micro inspection, which we all know about. Between that and the 2 IR is what's called the Sirot's gap, and we are at the high end of the Sirot's gap, at the low end of the infrared spectrum. There's some definitions there, so 1 micrometer is a millionth of a meter, nanometer is 1,000 of a meter. Anyway. Okay, next one please. Okay, so it's electromagnetic radiation. No, everything in the universe emits RF, some description, including urine. Because anything above absolute 0 is an emitter potentially of radiation. You heard about the Big Bang. You still hear the movements of the Big Bang about 4 Kelvin, if I recall correctly. We are about 37 Celsius or 310 K. That means you actually emit electromagnetic waves, radiation around 9.4 terahertz. So lots of transmitters in this room.
You've got licenses for that, eh?
No, that's license exactly.
Is it?
Because
It is.
the lower end goes to 3 terahertz.
Yes, everything I say is something you do not require license for. SWs can play with as much as they like. Okay.
Don't require license for yet.
Give them ideas.
Okay, talk about the sun, also something about 5.5 degrees Kelvin, no, degrees C, which waves are about 480 terahertz. Sorry, next slide please. Right, now we're talking about black bodies. You are all black bodies, believe it or not. Black bodies is a theoretical idea, a bit like the famous isotropic antenna, which you always try to get beginners to make. Just for a laugh and they can't do it. Of course, no such thing as a true black body. It's a theoretical idea. But whatever, if you have a black body and you hit with radiation, it means it will remain at that concentration and radiate. If you have a white body, it will reflect all radiation that hits it. So that opts away that it will look white. But we don't really have that. We have normally in between with grey bodies. Okay. So you can see at the bottom line, surface reflects radiation well with emissivity, like polished metal. Radiates well if it's black coated metal. That's why you have your heat sink is black and not silver. Next slide please. Okay. You can see here there's a number of different objects, oil and water, within the body, steam iron or hot plate, green. The hot plate is obviously the best radiation device you can get. There's a number of experiments discussing this. Google bags of frozen peas. God knows what he knows, I must have thought of him. Okay, we can move on please. Ah, right, okay, and you all heard of Boltzmann's law. Exactly, nice within my measurement. But if you look at the objects, T, P is the actual power you get from a plate heated to degrees Kelvin. C is the constant, which is Boltzmann's constant, and the area is square meters. So, in other words, you want a decent infrared transmitter, you make the plate as large as possible, as obvious really. That's just how you can prove that. Next slide please. Right, that's just showing you roughly where the infrared will play. You've got infrared up top, visible light down the bottom, remote control your TV. Now, that's just how the cursor with your TV remote control, but just gives you an idea. You're just getting a little bit higher in frequency than the remote control. Okay, next one please. Just shows you where the 37 inches, the band, it's 5.5, 14 micrometers. It's actually quite wide. Next slide please. Right, this is a very interesting one. This is volume, this is through here. The losses are minimum at the 30 kHz band, maximum just below it, maximum just above it. That's one reason why I use the 30 kHz band. Okay, so next one please. Right, yeah, this is a very useful device. Wireless relay. Oh, plate sensors. The detector in this is very useful because it's a, that's what this detector actually looks like there. And we're using that detector for measuring the infrared radiation from the source. Someone's asking what this detector is. It's called 9614, is it? And they asked me on MX9614. It is. Great thing is that as I see the interface, so interface with Arduino. And you also the big great thing is use Arduino's, the library actually includes this device. So you've got to know anything about the device, you just use it. The library is control it without having any complicated programming. Next slide please. Okay, thermocouple, that's how it works. You all know this. Who's got our families who use at home? Same principle. Heat the heat, thermocouple, the RF, and it produces a voltage which shows the meter. Same principle here. Cold junction, hot junction. Two different wire types lines. You heat the junction, you get the voltage out. That's exactly how this sensor works. Next slide please. That's it if you want to fit. You see it's a thermopile. It's the same as what I said before. Also has the processing available as well at the top. Costs about £7 this chip.
They bonded wires, Chris.
Yes.
We'll do that yourself.
Yeah.
All worth it for £7, is it? Next slide please. Right, this is Barry's sort of person. You can see the first main bays. He's got a sensor here, focus of the dish, which is used for collecting the radiation. Takes off the amplifier. Actually, it's really an Arduino which is using. Now you convert into a sound and also meter reading. That's the radiation from that device there. What else is used for that and the meter laser? Also loudspeaker. What happens is that device, providing the device has at least 2 degrees hotter from the surrounding area, relying the remote sensor to detect these humidity devices to these hotter than the surrounding score valid signal. Next slide, please. There's a cake there, that's the receiver. What we've got is the device here, that's the sensor. This is the display to insect. This device on the dish line switch now here, on here. This is in demod mode. Oh, sorry, line mode. You can use that on the meters to show you how if the dish is correctly aligned, and when it's aligned, you switch to demod mode and you get told the signal's present or not. So the output will also show the meter and also gives you your output here. The threshold control, like a spurt control, I think it's got officially built thresholds at one time on some receivers. The idea of that is that it will enable you to still receive the signal if the background is hotter than the actual device. So if I'm trying to detect that plate, okay, it's a hot ball that's been heated by sun, but I can still do some. There's a cake and barrel supply stuff for a charge for you. Now, if you don't know anything about hardware, they're marvellous devices. One like that costs about £5. Anyway, it's a program, you can do it by USB cable with the PC. All the software to burn it and everything is available on the web free of charge. Next slide, please. Right, there's my receiver. At the top we've got the input from the sensor and from the dish. And the threshold controls up there. And also the screw threshold on the ring. It's in peak mode. Also the reading the object temperature and the sensor temperature. But you only get this information in peaking mode. If it has a bad signal, it will show you in demod mode that it's got bad signal, so change it to receive. Next slide, please. Back one, please. Right, okay, this is my instructions here. That's it, what I've got is an 8-inch thick aluminium plate. It's heated by 4 50-watt resistors in series parallel. So if you work out 1 total resistance, filling up with 13.8 from the cheapo switch-on power supply, and it takes about 190 watts of power. Give me a reading of 63 Celsius. The power supply is the cheapest 30 amp, sorry, well, so I've got 20 amp there, but I've now upgraded it to 30. 20 amp will actually do it because it's only about 17 amps for the heating and about an amp for the rest of it. But I found that the 3 amp one was perfectly okay. Got rather hot, so I decided to replace it with the 30 amp one. Okay. We rotate the source, that's the rotation part there. By a stepper motor. It's again under control, and what we use is PRSS3. Who's ever heard of PRSS? Right, yes. If you're into that film now about your assets, you seem to see that be very, very slowly. Very slowly. For example, 1 dot is 3 seconds.
Bloody fast.
So,
That's 10 times faster than we used.
Perhaps it should have less S's.
so let's say that if you want to see which are, it's 3 seconds for the dot, 3 seconds for space, that's 6, 9 for dash, it's 3 times the dot, so that's 15, and 3 seconds for space. So you're going to spend about 18 seconds to see the A. Not really fast. So that's one way to do that in a minute. I've also got the plate mounted stainless steel box I had made up and rock brought back for installation. It makes it easier to control back and side radiation from that installation away from this. So a friendly metalwork guy who I know will
What's that packed with fiberglass?
rock wool, which you get from builders. It's a lot of sort of stuff. They put this on bricks now to insulate them. Thanks very much. Next slide, please. Right, let's see. Transmit the diagram. So you've got this stepper now, simple job by the A stepper. Job by TV660 controller. Job by the unit, unit on the O. And then you also you put in the information and press the keyboards. Now the key. This keyboard again. They're quite good because the Arduino knows all about PC. So you use a PC, you have to learn how to program the Arduino to look after the PC. It will do it all for you. Really very easy. So that is the front, which will be red when it's sending, green when it's not. And you can have it replacing on that controller, but that's all the transfer is. So simple. Next, slide please. These berries, ones are in now, and these synchronise the drivers. You can buy all this stuff from eBay, please take it is. That's all basic, and the transfer on my side is different. That's about it. Next slide please. Okay. So, what we do, I want to choose. Here we go. First thing first, if I turn up the short sound to go. There it is. Okay. Now put your clothes on this.
That's the first time I've been on this band.
Yeah, but which course on it?
Okay. Dashes and dots. Yeah, I see. I hear somebody try and copy that onto the.
I was thinking the way we had to speak it.
If you want to be a moron and try and copy it, then you can use it. And this one actually will copy process through. The barrel tried 16 cars in 2 weeks. We've got 2,000 actually works. This one works well. I can't tell you now because I've got a best for doing because I've had to switch it on. So the also I see it's got some of this. I say it's all very well having a carrier that you can see the signals, but you've got like some form of modulation. This is why it seems to be good, this is why it seems, accessory. Use it, try and use it faster, while you rotate with either speed or modular differential to normal.
How fast does the receiver actually detect it? How long before it gives an output from getting the signals?
It's got to receive the character in time before it gets it. So
No, I mean the infrared receiver. How steep is the slope? So that what I mean is, if you went faster, would it still decode? Would it still detect it?
I would think so, but I think it
That's to cool down.
That's what I mean.
Yeah,
It must be a minimum time.
I think it's about 16 hertz.
Is it? Yeah.
Yeah, so we're limited by that, not the receiver.
Well,
So
so
there's
yeah.
essentially ways to do that.
If you can do 16 hertz, presumably you could put a 16 hertz chopper on front of it and then build a lock-in receiver at the other end, and you'd significantly increase the.
Well, certainly some good ideas, and I've seen some ideas like that
It
come
must take
down
a
into
little bit of time for that to cool down.
Well, that's what I was asking.
Yeah, you put a shot.
Yeah,
No, but you put a spinning stack cooling down, a lock-in receiver. So
Yeah, but there's still time quick.
yeah, many.
Because the device is so small, it's not very much to come back, so it's
We could speed this up.
you wouldn't do it.
If you had a bit of scatter point, they use phase shift keying.
What you want is a constant heat source with a shutter.
So you,
Actually, better still, it's an analog sensor. So you could use AM. You could vary the amount of on a reasonably fast issue.
On a couple of steps.
I did say I'm going.
Yeah, you could go 50% then.
I did say I'm
Yeah,
going to shop something.
Then the resistors could take an infinite amount of time to cool down.
No. You leave the resistors hot and you use a shutter.
Oh, modulate the shutter delay.
Shutters are quicker than
Yeah.
lasers. Or find the right infrared.
Oh my God.
This stuff is market because it's something
About 2.
Yeah, we've got one on the wall.
That one?
No, he's going online.
So you want to do that?
Back, round, forward.
All right, then do it. Really?
Previous now.
Oh,
One more previous.
Right, okay, I think Roger first recognised this photograph. My back garden. This is before I had the some box made for the rotor. Put the input leads into the transmitting line across to the keyboard. It's cool time nowadays.
Sorry?
It's a cool time.
Yeah. A bit slow. I've got a bit misled at times.
But my play back a bit quicker, you see.
My CW's never that good anyway.
And get FTH working this time.
Okay, the next one. Right, okay, so this is what QSS3 is. Patience is required, I think we'll understand that. Patience is required. So, QSS1, which is what Barry was starting to find, the inertia of the rotor was too much over swing. That means each dot lasts for 3 seconds, so the short message seconds of the first minute. Cool. CQ dials the arm bit. Takes 3 seconds, 2 7 seconds to go through it. And the QRS on 1 seconds, goes on the QRS 2, not 3 1. Now Barry did some really sites users, so I think people actually try to take it down paper.
I need to get a stopwatch for that.
And for that reason, you could use some software like Argo or Space. So the next one should show that's it. Shows Argo.
Alright, that's good. Yeah, that's much better.
Now that's you can read some more backwards on this. That's right, so that's one possibility, or the other possibility next slide should show it, I think. Yeah, you've got more to this. Not to say Barry worked for 2 weeks, you've got 6 versions, different people's versions. Actually, I have no faith in the received ratio for useless. But when it comes to manual generated Morse code, it works pretty well. What we have found on this, we used to see celebrates a single like 4 T's.
So if a bird flies through it, opens it up completely.
I think it's a lot of better checkers, so it's lots of work, access 3 speed, which we really done. I can't think of the next slide, please. Right, we are on the great house. We use the sun as a salt. Or a hot plate, use the sun, you've got the sun working right away. Got it away. There's lots of threats on it. Each time as it moves in the sky.
You have to steer it.
That's what Barry can do.
That's what heliograph.
Yeah.
Yes.
Yes. But it's not working on light, it's working on heat, you see. You know, you shine light on this sensor and you shine heat on it. Where would you always have to?
Can it work off moonlight? It's called moonbound.
I was doing salt up for 6 hours, so take your hands, the heat from your hand.
Right, okay. Just stand where the sun used to be.
So, Barry's working on this. What's it? The sun moves in different ways to the sun, some day, etc. So that's all looking at how to get the thing working quickly. I think the next I should show you a bit better. Yeah, you see here in midsummer, the sun. Yeah, straight on, it isn't quite into the same, but that's all straight line. So you need to adjust the angle of the device if you see the sunlight from we've done it a couple of ways. Next slide, please. Okay, as we've got the strike over, so you can use GPS. To give you the information months got it working. I mean, that's the answer. But of course, we also need to do elevations as well. So we'll go back, please. Next slide.
Go back.
No, forward. So it's got actually strive to follow the sun. This side's at a very rate. Well, this is what happens when you're time from the real world, so it's quite a challenge, I think. That's actually the next slide should show up, so we've got elevation yet. One part of we've got the elevation, which I worked out. This is the crossroads and step roads and something, which I worked. Okay, next slide please. Right, so far, Juicy 5 minutes is not out various some savings or hot plate sauces or hot plate sauce. Because this one has been beaten out by some using completely different methods. But, you know, it's Barry has so far achieved 130 metres using the sun as the source. The site he used, I think, was a Finley site.
I thought the moon temperature went up and down. There's about a week's lag behind them. I think the surface of the moon, doesn't it? It goes up and down, but a week later.
It does. So I think Barry's idea of the sun is an idea. I think it was the way it was going to be real difference in performance. In the sun, I thought it's still sorts off in the sky. Most days it's there. If it isn't there, you shouldn't be out playing sorts off anyway. Because I'm touching your toes. So the different sorts.
What sort of bead width is that you see that turning?
Oh, that's very interesting. I think it's an ideal thing if you want to practice how you go to some lecture. It's very simple. Very accurate. It takes to set the thing up.
Yeah, so that's that degree or something.
That's an 8-inch dish from different sides. I think like a room that's it bands down.
The bead is set by the size of the sensor, I suppose.
The sensor is about half-inch, about 10 millimetres.
Yeah, even if you've got tops.
Yeah, then you find that would define the bead width.
The Barry reckons that the present receives our sensitivity switch by admission 30 hertz from the moon. You see, by some I'm actually trying it to do that better than the garden. It's like the really thick. That's what it's their own. That's probably about it, I think. Just check. Any questions at all before I finish? I'll apologise for my survey. I'm down on the question. Any questions from Wales? So,
Have we considered giving it some selectivity by reducing the range of wavelengths it can receive?
So I will be honest with something there for lockdown. Lockdown is only right for that.
Using professional.
And the next side should show that you can look. Yes, now Barry has written out most of this in Recon Plus. It's the current one, volume 16. So if you've got, seems to be a print skirt. Okay.
Something
You can't seem to print on the American Plus article. Okay, view of it.
Yes, it's due out soon.
Oh, the second part, sure, so that part is actually out now. So the second part is good. So if you want to look at all the things like switches or you put the words guards and programs or in very old school. And finally, if you are interested, let's say, you get all software free charge from Crawley. It tells you I'm the only other GM that ever had software in this country, but it says several straight to us. It's not to say this season of mine. That's about it, thanks. You can sign off this on the next slide.
I'll have to set aside 2 days for that. Thank you.
Okay, Chris, thank you
Yeah.
very much. Do you want another break or before I call you all?
change the air a bit.
It's getting a bit hot and stuffy in
So it's purely down to the slowness of the transfer rather than the travel.
I can hear a tone running.
Yeah, CO2 level. When you've got it down.
It goes off after a while.
Someone's got in the line.
Oh.
Unless you use something like a liquid crystal switchboard.
Mirror flat thing is probably very close to
Trying to see how quickly it responds.
Yeah.
Changing the jack to the chopper.
And then still blocking heat.
Yeah, but there might be some processing delay.
Yeah, it's probably if it's interrogating the price that I do see, probably that's probably part of the time.
You don't really like that because like warm air.
It just doesn't respond to light.
The mirror is those chunky devices.
Yeah.
Put put your hand on it just a second.
Yeah.
Put your finger in the fan to see if it's getting out.
So are they Mitsubishi blocks rather than
Yeah, they are the Mitsubishi.
not the standard?
We dirty the lot of these shots.
They're marked differently to
Yeah, they're
ones I know.
Well, they're different. That's why they're BGY. Oh, okay.
Yeah, yeah.
No,
That's
they're
right.
not Mitsubishi then.
No, but the Mitsubishi or Motorola ones, you can still reasonably get decent ones off eBay from China or wherever. Oh, there's another yeek for you.
There was a little filter someone had as well. That's simply gone. Yes, they're all the big utes. I never see any of the nice one button jumper ones on the market.
Yeah, so in work we bought one of the new Future Tech V&A's today.
Yeah.
Which, and I have to say, no, you pay sort of real money, no, sort of 6K for one, which is the top end model, the DC spec. But its performance is, and its software is so comparable to your actual proper
Because with a company where I did my very first DSP base, they came out with A to D converters.
Oh, they've got all sorts of oscilloscope data.
It's on a parallel port on a PC.
Oh, right.
It's the first time I ever come across an A to D to connect to PCs. So I actually wrote DSP using software timing loops written in BASIC to generate the sampling rate.
Yeah, so they have lots of, oscilloscope things which are nothing special, but V&A is it's almost worth a laptop review because it's almost a formal practice.
Bigoscope's always done some like this stuff.
Yeah, well, I downloaded the software before we bought it, and I thought, this is, without having to pay 3 times the price for the key size. Yeah, the oscilloscopes, their software is awful, really. But they've got such a range of cheap choices, not an issue.
But there are some.
And then in radio spares, there's the RS Pro range, which is basically a Chinese equivalent to the Picoscope ones. Software bit radio. But
Well, you've got a year to investigate them, and you can come back and talk about them next year.
One thing that wasn't stock recently was Leo Bodnar still got reasonable capability on his reference.
Yeah.
So we're buying dozens just to make sure that we could get hold of some stuff before it all dried up.
Alright, I'll just show it.
He's got, it's just I think the one what's it close to I've never played. And probably that now.
Oh, right. Yeah.
Since it's USB interface, probably 5.60
Yeah, I wasn't too sure behind your things, but funny enough, I did have a load of PS2 keyboard converters on.
What, online?
Yeah. So basically, the neighbour picked it up on that. It's so bloody easy to see that.
Yeah. Well, we so the back of servers until very recently.
And I said to myself,
Particularly,
it might
they
be
didn't like using
USB.
So all the KVMs that we've recently had to buy the little converter.
Well, the
expecting that keyboard. Some receivers quite good. Some keyboards
put that in the car, or
I only saw that half day or so.
I've got a question on the
Okay, that's
Minor problem with your website decides that your website.
Is it still streaming?
Probably.
The case. No. It's a good switch.
Sorry. Maybe we'll cover that. That's what we used to do in the oldest labs on the ships.
That's right. The constant light, and you just turn the light.
Wonder if
The only thing is it's heat, it's not light.
yeah, but it's still blocking.
Same principle.
If it was aluminium shutters, it'd still block it.
They would eventually.
Yeah.
You might only have a short window.
Yeah, when it worked.
If you send faster,
That's what it
Yeah, they're
is.
over.
Yeah, you'd have to have. I don't know, if they were painted white, they would reflect the heat away so they wouldn't heat up that much. So you might get quite a quick switching by doing it that way.
It's worth a try. I've got an old lamp like that up for sale.
It's got to be set by the size of the sensor. Be purely There's no way it can be set by the wavelength
So,
of the dish.
the answer normally is no.
All right. Okay. Brilliant. Thank
It's like light bulbs.
Good.
It's the LEDs and light bulbs in the same.
Looking,
It's the size of the filament.
it's not very
Yeah, so you've got projected an image of the filament.
So in which case, you'll just do geometry.
I was going to ask this
Probably
all the last minutes.
These there?
Always yeah, we've got minutes and we've got stuff on the outside. Just one last year.
1.7. So, yeah, 3 minutes.
Yeah,
Yeah, I think I've got
but this one, the point is, it's the anchor place.
Are we still looking for the
Yeah.
I don't.
It's likely.
It's good that we.
Perfect.
At the moment, certainly,
Ah,
having
well,
a
okay.
flash up.
Right, well, that's it. I do want to
This one.
So I need for high frequency.
Yeah.
It might be all of them are the same problem, aren't they? They could be potentially.
Change.
And may have been.
Oh,
Yeah, we've not really got much use of that anyway. We've got definitely thicker one.
Because I came across on the Ofcom website a question, and I think there was just like 3 replies to that.
No. I recognise that. That's very
I wouldn't expect any replanning policies not to try.
It's a 2 metre noise.
So here's a news flash for you. Ofcom aren't waiting for the consultation.
It works very well. Because you've done demonstrate something like that down at the call sign's rubbed off, so I can't quite. I was hoping it was going to be there.
And I didn't like it.
Yeah.
Yeah, and then
Wi-Fi
or something with a curve at the bottom. Yeah, it's not an end.
I reckon that's an end. Would you say that was an end?
Yeah, but there's something between for this.
Yeah, it could be the second end.
No, there's something.
I know NNS done one. Yeah.
Well, it's not even.
I did one, and YTS did one.
If you were to check loads of other things, if you were to check, there has not been a formal requirement.
That's what it says. Guess what it says? For JNC. I've just rubbed over it. You can see it if you rub on top of it.
Oh yeah, so did. In which case, so you're the car. Who's the other one?
Probably that one. I just rubbed the thing.
LVP.
Right, that's good.
Who's LVP?
Here's the most of the qualities are.
Oh, I remember the design. I'll cascade the mod out. I don't remember.
Yeah. Anyway, I referenced it to Mike and thinking it was G4 and NNS, so I can change that when I talk about it.
G3 LVP. Yeah. I don't remember Everton. It must be LVP's implementation of my design. Oh, LY, please. Mike. LY. Yes, it's my playing out my design. Yeah, yeah, be careful what you latches.
The risk.
You rub the finger over it.
I know the three of them all people like that advertise.
Make sure it's not from.
Yeah, Mike laid out.
You can tell them how it works.
Let's see a cascade of products.
I found something the other day that had my call sign on it. And I do not remember ever making it. I cannot remember ever doing this project. It says I've made it. It's in my drawer, so I must have made it.
I've actually put questions on that because I couldn't work it out.
On
You can see it now.
We're deeply engaged.
I thought it was G4 NNS.
No, he's done something
He done something
vaguely
similar.
similar, but for the radio astronomy people.
Oh, right.
Okay. Or 1.6.
That's very siloed.
The hydrogen frequency anyway.
So it's a noise output.
What?
Yeah,
Noise a high gain, really
Yeah,
high
I
gain.
think I think it's got about 90 to 100 dB gain.
And you just put your track of sound meter there and you can see the sun noise and the moon noise.
It's very high gain.
Yeah.
Has to do more in stuff than shot. Or have been so overwhelmed with demands of the room. It's
It's a struggle.
And we did
After I hire a van.
You might get it on the roof rack if you want.
Yeah.
Another time.
Oh yeah, well I didn't reply on that, but I sent a note. You've got no evidence of what happened. And this was on The whole, no, the BLT where everything's ready. Wherever you are. And there's gaps on Twitter.
You're doing this, right?
No,
Oh, yeah.
No, no, but
Operating.
Well,
Well, I'm learning. I've just figured out why the dimmer didn't work.
it does, no,
Focus.
Put the GRO thing dish back up.
Oh,
by the
right,
microwave.
okay.
Right.
Yeah,
They don't take it away.
Ah, gotcha. Now, who's doing this? It will work.
It will work.
I've figured out why it won't work.
Wasn't plugged in.
No, it's focus. It needs to be focused on the window.
Have we got thousands of viewers?
Oh, I don't know. Let me have a look for you. We have currently got 10 viewers. 8 viewers. I've just given up. But you've got one like, look. One like.
Well, pretty much we didn't tell anyone it was going on.
No, I'm learning lots, so that's a good thing. It
Well,
does
if
no
it
harm.
works next year, then
We'll have a much more sophisticated setup by next year with multiple cameras, a microphone, wireless microphone.
It was Richard in Australia who sent me an email saying, I see you're doing a talk at Crawley. Any chance to stream? gain amplifier takes in the 2 meter IF from the transverter, and then gives you a RF reading coming out the output, and you feed that into the Hewlett Packard power meter, and that's the inside of it. That was before I scraped off or Colin scraped it off. And I could see something like about 4 dBs of sun noise, which I was quite surprised about. But I also then sort of moved the dish around, and I could see the buildings, and I could see the trees and everything else. It's a standard transverter as it was then, so it's got about a 1.2 dB noise figure from CUNA, and it wasn't locked, and that particular one is still locked, but it carried on. I thought, okay, I could see some sun noise. Let's have a look at, see if we could bounce some signals off of the moon. This was just before COVID came down, so I'd spent quite a bit of money and bought myself a spin rotator. If I'd have known then what I know now, I wouldn't have brought a 1 degree one, I'd have brought one of their high resolution ones, because the dish, when you get bigger dishes, you need to be able to track to 0.2 or 0.4 of a degree, not 1 degree. The moon moves outside through, just through quite quickly. So after that, I thought, well, to 75 quid, I could upgrade myself to a 1.2 metre dish. This is a standard satellite dish, which you can buy from any, dealer or supplier. And unfortunately, it's a bit flimsy when it comes to mounting things on, but it considerably gives you a lot more gain. That thing in its own right has probably got about 40 dBs of gain, whereas the other one only probably had 34, something like that. So we thought we'd have a go at the geostationary satellite, as that had just been on about 2 weeks. So we went from there. I put the system up at home very quickly just to prove that it was going to stay upright on the patio stand, which I already had. That was only about 3 foot off the ground, a standard 1 metre pole which came with it, and they're only 600 by 600 slabs, and there's 4 of those concrete slabs, and that enabled me to sort of move the dish around, and I could hear a couple of beacons, or I could hear 1 beacon on that, which was GB3 PKT at Clacton, which is about, I think it's 45 kilometres away. So, and that was looking through, well, I think the slide says. Right, I then put the potty feed on, courtesy of Colin. Colin made up the metalwork, and I put the LNB, modified the bullseye, is it? LNB, and put that on, and spent a good 3 months working the satellite before I decided I wanted to go back to terrestrial work and maybe some moon bounce. Going away from the satellite feed with the potty, I then got a DGU, or GW4 DGU as it was at the time, feed, and installed it, and again heard the beacon. And this was looking through a fence and a house next door. So, I had quite a good system to be able to hear that through the house and the trees and all sorts. Extra waterproofing was needed, so Tesco's carrier bag went over the top and just kept the water out. Biggest thing when you start putting things outside in dishes which are moving around is that you've got to be aware that water's going to get in. If you look at this item, there's loads of packets of silica gel in there to absorb the water that should it get in there. And we found out from the 24 gigs beaker, but when it does get in, it can do a lot of damage. Right, this was my first ever decode off of the moon. Same system as what I had there, but I was using for a straightforward transverter, no preamp or anything, and I heard OK1 DFC. That was on the 7th of February 2020. So that was just as we were going into lockdown on COVID.
Is that Q65?
No, that's Q64, was it?
QA64, the old one.
Yeah, the old one. And then I think there's a display there of a Q60. No, what was it? QRA 64. And it just shows you, I could just see a couple of decodes on there. And in those days, where the red line was where it decoded a signal. That's gone away now, they don't do that on QRA 65. So that's showing the waveform on WXJTX. And obviously you can imagine how elated I was that I'd actually heard a signal from the moon. You can tell it was from the moon because of the 2.9 seconds delay. If it doesn't come from the moon, it doesn't get the delay in, and you know that you could be hearing the guy direct. Then another weak decode. Look at the levels of the decode, -24. You know, I'm obviously getting signals, but quite weak. But then that was Portugal, so again, that's 2 stations I've heard now off of the moon, so I'm on a roll. And this, when you've got a 1.2 metre dish, you are very small fry. You know, you're at the limit of being able to hear a signal or not hear it. Especially them hearing you, as I've found out to my own peril. Right, and here we have the first ever decode off of the moon beacon. The moon beacon had been off the air for three months because the transmitter had blown up. And Charlie, it came back over to Charlie in Northamptonshire to rebuild it. And then Charlie had sent it back out to Germany and then reinstalled it. This was running, well, it's a 50-watt PA, and I think they were running at about 27 watts. So that's a -20 decode on it. That was March. So again, I was very pleased to hear that. And a few days later, I've got all of those decodes, and over a period of time, that means that dish is tracking the beacon reasonably well. If you notice, they're all about neg 22, neg 23. Well, there's an even bit better one there at neg 18. So again, I was very pleased to be able to see that everything is working. But you can just very faintly see the display lines. I can't over here of the tones. These are the still using QRA. No, sorry.
QRA 64.
64 still. So I use a 970, and with the 970 and then WXJT, it will also account for all the Doppler shift. So you actually set a frequency in, which is anomaly 024, and then the program works out the Doppler shift for you off of the moon beacon, and then it automatically steers the IC 970 and corrects for the Doppler. So apart from pointing the moon and then keeping it in track, the computer is now controlling most of this for you. So it does make life a bit easier rather than have to go outside and move the dish every 2-3 minutes, come back in, move a bit more outside. Right, then I made another investment and got a Cume preamp. As you can see, the beacon is a lot stronger, neg 9, neg 9, neg 12. So it made a vast difference. Still using 64D at this point, but considerably better. I'd been using it the day before, listening to GB3 PKT, but I decoded those. That was just what was left in the memory of the WXJT. Right, transverter preamp and changeover relay. I mounted them in some Morrison's boxes, and then Leo Bodner was then put into another box. I think I'd upgraded to a G3 transverter module at the time from Kuhn, and that was put in with the preamp. And I also put a built-in relay so that when I did go to transmit, I had that already built in, the loss from the relays. So I knew what to expect once I'd rebuilt the system. At this point, at this point I turned the dish up the right way, so it's now vertical. That gave me a greater height and gave me a longer boom window, because when it was at 1 metre on its side, I could only see from about 20 degrees looking over the house roof. Changing it to that took me up to 15 degrees, which gave me another couple of hours moon window, which was quite useful. I've also strengthened the base a bit with a couple of bits of angle iron, because I found that with the bigger dish in the wind it was moving sideways a bit, so that helped out. Right, John BAO was also going to be here today, so I put this in knowing he was going to come. That shows him having a QSO with OZ1FF. I didn't actually manage to decode John, because John, like myself, only uses a very small dish. I think his is a 1.1 metre dish, not a 1.2. Although at this point, I don't know, he may have been on his 1.8 metre dish. I'd need to check with John, but thinking he was going to be here, he could tell us, but he wasn't. So, but there's quick mentions of John's call sign. And there's another signal from W5LUA in the States. He runs a 200 watt to it, and his signal was as good as the moon beacon. As it's showing neg 10 on his, whereas the moon beacon that day was only showing neg 15. Right, that's what a very strong signal looks like on WXJTX waterfall. The white bits are the 64 tones, and the start bit, which should be around 1 kc, is considerably stronger at sort of a neg 10 level than what you could see when you're receiving neg 24. And that signal was audible out of the speaker, very clearly audible out of the speaker. Just another one to show is VE4MA. So the system's not working too bad. I now can hear another continent besides Europe. I can now hear across the water. So I'm getting more and more, how shall I put it, elated with what I've been doing so far. Remember, I'm only working on receive at the moment, so I'm giving people receive reports rather than actually transmitting on another bit which I'm going to come up to in a minute.
I can assure everyone that as a recipient of the WhatsApp messages that were being sent out, he was very
happy. Well, it's, you know, it was on my bucket list that I was going to work the moon, and I said, well, I'm going to have a go at this, and I did. So, well, this is a different view of, this is showing the PST rotator display as well. So you can see there's a nice strong signal there coming in. I don't know, that's DL0. I'm obviously getting a nice decode off him, neg 12, so it's fairly strong. The rotator is doing, that's what's controlling the rotator. I don't have to go out to the dish anymore, it's being steered by the computer. It's not working quite so well now as it was. And then that's giving me another bit from WXJT telling me what's going on. I've got that on a constant frequency off the moon, which is constant frequency off the moon means that the Doppler shift is calculated for, by using that, it calculates the Doppler shift to put you onto the nominated frequency from both of the stations who are having a QSO, so that you could be listening on their same frequency and hear both sides of what's going on. So if you put in there, what is in there, 157, they were probably on 150, yeah, 150. So it's calculated the Doppler shift for him, and then also the program calculates the Doppler shift for the other station, so they both come up at the same point. So, and likewise, when you go back to transmit, when you're on transmit, it also calculates your frequency and offset to bring you back to 150. So 3 or 4 or 5 stations can all have a QSO on 150, and the program sorts out the Doppler shift for each of them, so you know where you're listening. So you don't have to sit there and calculate, oh, he's going to be 15 kilohertz high, no, he's going to be 12 kilohertz, and then retune each time. Constant frequency of the moon brings you back, all back to a nominal frequency, which is a very useful feature. This was the operating position at the time. I've just running off of a laptop. I've got that, the 970 there, but I'd actually brought a bigger screen so I could run off of an external screen as well. This was just before the builders moved in. We were having a new kitchen built, So I was expected to go QRT for 3 months, but other things came along at the same time. COVID unfortunately closed us all down.
There's not to answer for it, isn't it, Kevin?
Sorry?
There's not to answer for.
It's got a lot to answer for. I put the shed on order. They said it could take up to 6 months. That turned up a bit early, and we'd only laid the base 2 days before, so he just left the shed in a pile of bits, and I then rebuilt the shed. He was paid to actually build it, so unfortunately, because the concrete was still wet, I couldn't have the shed put up. So we put it up in the end. You can see the dish lying down on the side there, waiting for this to go. I can't operate in the house anymore because it's a building site. COVID slowed that down. We couldn't get the materials for the build. We couldn't get the double glaze. We couldn't get all sorts of things. So it really did make it difficult. So I was off the air for a lot longer than I'd hoped I would be. Anyway, once we got the shack up, I plumbed all the electric myself, and got a friend of mine who's he runs an electrical company, and he came along and certified it all for me, and got a certificate to say that it was connected on the mains and it wasn't going to blow anybody up. That was another step forward to getting back on the air. Right, and then I must have spoken to Jen, one of the, I can't remember where it was, but you said you had a TW 25 watt TWT. So we arranged to meet up with Jen during COVID, separating ourselves. And I went down to his house outside Maidstone and picked it up and got it back. Spent £100 on a box to mount it in, which was all going to be all waterproof. Only to discover that it was probably a bit too heavy for my liking. I got 12.5 watts out of it after I'd gone through a 2 metres of cable, which I was going to have to mount it on the back of the dish because there's no way I was going to be able to mount it on the front. So because I'm using an all coaxial system, not a bit of waveguide in it, I suffered quite a bit of loss on the cable. So all in all, it was not the way perhaps to go. Right, the other thing I use, which is probably, I don't know, some people might do it, is I feed 144 megs, 10 megs, and I also do the PTT keying down some triplexes.
So the military do a lot more than that.
Oh, I'm sure they do. But
five signals.
Right, okay. Well, I've got one coax cable, and it does all of those through. So it's, you know, it saves running lots of cable up to the mast, especially when you want 10 megs, your 2 metre, and then a separate PTT drive. The 970 at that time, you had to buy a separate module to key the bands up if you wanted external PTT. So I went about it that way. So I just switched the other end of that module. There's a relay input, and it just switches it on and off at the other end. Right, and then disaster. My retina detached in my right eye, and this is me looking like I've just done 10 rounds with Henry Cooper. That was about a week and a half after I'd had the emergency operation. So anyway, I then started on actually building a new base. As you see, I decided to take it up a bit, and because of the Ofcom ruling about the EMF, and I thought, well, if I get my dish up above everybody's head, I can't then cook them. So that's actually the top of that mast is 2.4 metres. So unless people stand in front of it, I thought I'd just be on the safe side, because I'm running, by the time you're running 10 watts with 40 dBs again, I've got 40 kilowatts ERP. So.
You're safe at anything other than the feed.
Well, okay.
Like if Turing did it, I was there.
Well, yeah.
I think sit on their dish would be safe.
Yeah.
200 watts.
Really?
Yeah.
Okay. Well, I just thought I'd be safe. It also improved my moon window, because I can now work at 8 degrees above the top of the house. So I've increased my physical time of working off of the moon. In the corner of that lot, there's 4 75cm stakes at each end. The mount is going nowhere. I can sit there and do that, and it just about moves. And I live on the Isle of Sheppey, so the only thing which is going to move it is going to be the Montgomery, should it go bang. Isle of Sheppey, we've got yeah. So should that go bang, it might move it, but I won't be there to know anyway. So
SS Richard Montgomery.
that's it. It's a 10 megaton nuclear bomb, they reckon, should it? Anyway, the there was mounted a dish and the skid rotator onto the new mast. What we obviously, now you've got it 2.4 metres up here, it's not quite so easy to lift up. So we managed to get the spid on, and then by rotating the spid down, we were able to then push the dish up and turn the dish round. You can actually take the spid down -15, recalibrate it, take it down another -15, recalibrate it and take it down another one. So when I park the dish, it's actually, the feed in the dish is horizontal to cut the wind surface down. Right, this is the new expanded operation in the shack. I've now got a bigger monitor than I had before. I think somebody gave me some money for Christmas, so I've got a 24-inch screen there, so it means I can see 4 things clearly going on there, plus watch HB9 logger, which is, HB9 logger is like a moon bounce OM4 KST. You go in, you get a password, you put yourself on it, and it's only people who are interested in moon bounce. It also gives you different bands going across the top, so if you wanted 1296, 23, 13 sems, 5.7, any band you're interested in, you can go in and monitor what you want at the time. I've got 10 gigs there, and I think I've got 1296, and I think 24 gigs was the other greyed out box. It's like a two-way conversation. You can go in, type in where you are, what you're doing, say you're calling CQ, what frequency you're on, and what mode you're using, CFOM or whatever, and you work them, and then they come back and tell you on this mode at 73s and whatever else. So it's very useful. If you use OM4 KST for contests and the such like, not what you should do on some bands, but if you do, it's a very useful feature, HB9Q, because the only people that are on there are people doing moon bounce. And you can get random QSOs just because they tell you what frequency you're on. You tune to theirs, select CFOM, and you then end up talking to them. You may not even know that they can see you or know that you're calling, and then all of a sudden you see their call sign pop up because they're answered you, in the next minute timing. Right, then the second disaster, this one's a bit more explosive in that such, because it was COVID at the time, and wherever you go in the hospitals at that time, you had to have masks on. So all I could see was a little bit out of that other eye. It became detached again, and I ended up at St Thomas's having an emergency operation to have it reattached for a second time. So I won't say my eyesight's brilliant, but there you go. I still keep burning the ends of my fingers. Right, having not been able to use Jen's transverter, I managed to acquire a 22 watt SSPA, which I managed to install into a box, which is there, which I took off of the mast last evening about 7 o'clock. It's got a slightly different transverter in it now, because I had a disaster with that transverter when I was playing with the buck converter to stabilise the voltage on here, on the SSPA, which had to be set to 10.4 volts. I hadn't transferred the voltage, the input voltage cable, so I fed something like 16 volts into the transverter, and it didn't like it. The fuse blew, I think, and which is a trigger. One of these it resets itself. And I think I must have let it do it 3 or 4 times, because I ended up blowing quite a few chips up, and in the G4, so or G3. If anybody wants it, it's scrapping my box if you want to play with it. But an expensive disaster, but there you go. I then fed a separate 12-volt feed up to feed the rest of it, and the 15-16 volts to go up to the buck converter to stabilise the volts. Another couple of little things. There's a fan sensor, a heat temperature sensor, which goes through to a module, again by Kuna, and that senses the temperature of the heatsink, and that switches the fan up in about 8 or 9 steps, and as it gets hotter, the fan gets faster, and then it then cools down. It cools down slowly. So I did notice that when we were in 33 degrees the other day, the fan was running, even though the transmitter hadn't been on. So the heatsink had obviously absorbed some of the heat from the sun. When you're got the dish looking at the sun, because when the moon's not there, I usually end up tracking the sun just for the fun of it. I'll tell you another story about the sun in a minute. And the box, because it was a white box, it was gathering on all the heat, and I think that's why the heatsink was coming on, so rather than reflecting it so much. Right, the aerial I got has got about a 10mm bottom tube, and how to mount it. So I've got some of these plastic pipe clips, which you use for putting on plastic water pipe, and I've got 4 of those slung underneath, and that holds it sufficiently. I've got a few cable ties to stop it moving backwards and forwards, and at that time I was playing with a lead, because I was still using it for terrestrial use at the same time, so the lead had to be slightly longer so I could move the feed through 90 degrees, because most of your moon bounce from Europe is done at vertical polarisation, so it meant that I'm 20 dBs down on the beacon because I'm on the wrong polarisation. So that I found that was useful to move the feed around to get between horizontal and vertical. Right, this is my first contact off of the moon, HB9 DUK. Again, I was so excited I forgot to take a picture showing the Rogers and the 73s, but it does show that I've given him a reading back of NIG 20, but there was a full complete QSO, which I was very, very happy with it indeed. It's now November 21, so it's taken quite a few months to get to this position, but at least we've done it. That was the very first QSO, NEG 17 and NEG 20. So, and the second confirmed contact, IW2 FZR. FZR, is that? Yeah. And we've now gone to a different mode. In the time that I took to build the PA and get that going, we've gone to Q60. Yeah, Q65. So we've now not using QRA. I think Andy done the Q60.
I did both of the beacon sources.
Oh right, okay.
It's actually made switchable, so when they changed over, it's just a case of clicking a switch.
Oh right, okay. So I was quite pleased with that, and I remembered to take the picture this time, and it shows the Rogers and the 73s. So that to me was the first complete one where I can actually show you where I took the right information down. So when you operate WXJT and you go on to transmit, there's lots of things going on which you've got to do. You can press automatic, but if you don't get a decode, it sits there and you think, well, what's going on? Nothing's happening. It's not till you actually get a viable decode coming back, which it then moves on to the next information. So there's several of them. You've got me coming back, saying 01, and then I went back to CQ because I didn't think he was hearing me. And then he came back and said he could hear me at NEG 20. So it takes a little bit of getting used to, but once you've mastered it, it's okay. Right, so that's the second one. Oh, and then lo and behold, a few days later, the first QSL card in on the doorstep, which I was very pleased. Again, I think I told Alan it had arrived. All the rest of the people on the pub where we go.
Going back to that previous one, if you actually look after the messages that come in, it's got that queue message.
Yeah, yeah, and that tells you whether it's complete.
Well, no, it's doing something even cleverer in the software. And
yeah,
I know we ended up having quite a conversation about what that actually meant.
But so again, he's using 1.8 meter dish. Yeah, 1.8. So he's got another 6 dBs on what I have. So on at 1.2 meters, I think I do quite well. So we decided on a bit more waterproofing. So Sainsbury's carry bag for life. And I'm still using the same bag, and that protects that when I go in. It's got 4 slots to allow the clips to fold over, a few holes to let the various cables in and out, and I just tie the bottom thing. I don't know if I've got a picture of it when I park it. No, I haven't. Just a warning to everybody, don't try and run 9 USB things off of a laptop. Eventually something's going to go. I had a splitter which split it 9 ways, but it didn't have any feed to it. So eventually that went short because I was obviously drawing too much power off of that. That shorted out the USB port in the computer. Smoke came out of the computer, and when I sent it back to Lenovo, they sent it back and laughed at me. So unfortunately I had to go out and buy another one. And I thought, well, I only have it in a shack, I don't take it out anywhere. So we brought a desktop one. The whole computer is in the screen, right? And you've just got a keyboard and mouse. So should that go wrong, I don't know what I'm going to do. But again, I've now got 2 big screens, so we're advancing even more. But just to warn you, it doesn't pay to take 9 things off of the USB port. Right, getting towards the end now. Last month's ARRL 10 gig CW contest, I worked in other 4 stations using QRA64D. After the Q transverter, which went wrong, the internal VCXO packed up. So I sent it back to Kuna. I spent 3 weeks in the post and customs to get to them, right? And then they fixed it within 2 days, and they expressed it back UPS, and it was there the next day because they found a problem, and they obviously felt sorry. Plus, I said I was going on the contest, so they sent it back to me. But as you can see, I've worked PA3DZL. So I think I've now worked 12 people off of the moon successfully. So things are getting there. Right, that's it. Time to wake up, everybody. And that's it, really. So, any questions? Yes.
Is your dish 1.2 across the face in its longest dimension, or is that the sales bit?
It's the sales bit, I think. It's his 1.2 across that way. It's about 1.35 that way.
All right.
It wouldn't fit in my car.
Yeah.
Same as that one won't fit in my car.
Yeah.
It's got a claimed 43 dB gain and 70% efficient.
Okay.
But I don't believe that.
Yeah.
I can. One of the other things I said that there was a thing about the 7300. If you run a 7300 with the full transverter gain, it limits on sun noise. So for a while, I could only see 3.5 dB of sun noise. No matter what I tried, I couldn't see any more sun noise. And then somebody said, "Well, maybe you're limiting it." So I stuck in the 6 dB attenuator in. I've only had 6.5 dB of sun noise. You know, the IC 9700 was just being overdriven. So when I put the transverter back up now, I just turn the gain down on the receiver, and that gives me, I can see 6.5 to 7 dB of sun noise, which gives me about 0.3 of a dB of moon noise. So I can actually see the moon, and I know that I'm on it. Don't have to have a beacon anymore. It used to be, but I used to have a beacon. I don't need a beacon anymore because I can actually see the noise going down with the moon. So
yeah, that's important. That when you're using the Y factor to make sure it stays linear,
yeah,
it actually get worse.
Yeah. No, it did. Why can't I get any more than 3.5 dBs? You know, it's incredible.
Question from the internet. There's still people out there. I'm not entirely sure who, unless somebody knows who Antibosh is. What SSPA did you use?
It's the PA group. Comes from the Netherlands. I've got his course on because I worked him the other day. PA 3DZL, I think it is. For some reason, the texture's right down the other end. Yeah, PA3DZL. Okay.
Very good.
I don't think he's got any more left, but he did have quite a few. That's it, really. Any more questions? No?
Where next?
So, who wants to buy? I've got a spare dish now.
I would wait until you've done the conversion first before selling.
Yes, I will do. Yes, don't worry.
That's a shame.
But I've got another one of these, which is smaller than that, so and heavier. But I've got the mount for that as well. So if anybody's interested and they want to try it, it's not too complicated to get going on receive, because you can do it with just one of the LNBs, the phase up LNB. You can get a signal from the moon off of that. So I think there's somebody doing it on a 75 centimetre dish, getting decodes. So if you've got a dish already, have a go. The beacon's quite strong. I think one of the guys was getting it on a 50 or 60 centimetre dish, and he was just using a moon, a telescope thing to follow the moon. So, yeah.
So I presume you don't need to see the moon visible. It can
No, you don't know.
still up there.
Believe it or not, there's a lot of
not.
people in this world who believe the moon only comes out at night.
Yeah.
No, you
time.
don't believe it, but
Is it-
it's only there for half an hour. You know.
It's going to be quieter if it's not illuminated, isn't it?
No,
So
the
sun
cloud has
doesn't-
a small effect on it,
Yeah.
right? But it's more where the moon is. It moves in and out from perigee to whatever it is. Yeah,
Yes,
and there's 3 dB's difference, or it can be.
Really?
So it's best to work it when it's closer to you.
I
than it is.
think the question is the moon quieter when it's dark
No,
compared when it's light?
No, it's not.
No, not really.
The moon heats up, and as I said with Chris, it lags by about a week, but it only moves a few Kelvin up and down. So, but they think that's because of the dust on the surface of the moon just heating up, and then it takes a while for it to go up in temperature and back down.
Your dish isn't high enough to get this bounce off the ground, is it? Is that another factor you can use?
I haven't got enough clearance from the houses to actually get ground advantage. I think.
And how many dB is that worth, if you could?
A few, yeah.
You can get out 10 gig, wouldn't you?
Yeah, I think so. They went down to Goonhilly, Crawley, WDG, to work New Zealand, not only to get the lower horizon, but it also I could actually copy it below the horizon because of some sort of gain coming from that. Again, it all depends on how well your dish is illuminated and how much. If you're over illuminated, you get ground noise coming back from the ground behind you. So it's best to run with slightly less, sort of 90% sort of illumination, so you restrict all the noises coming back from behind you. So.
Does the Doppler change with the moon being down on the horizon?
The Doppler
Because
goes
of
to
the
zero when
speed of
it's at a,
yes,
you know,
it
over the
does.
top, and
Yes,
it goes,
It's
starts
measurable.
it starts positive,
Yeah.
comes to negative or zero, and then it goes back down the other way.
Yeah.
So
you're talking 2 or 3 kilohertz on your.
you're talking 25 kilohertz.
25.
25 kilohertz. I've also tried 24 gigs of moon belts. While the transverter was away, I put my my 24 gigs terrestrial, and I can follow the sun, but I couldn't see any moon noise. And I actually got them to put the moon beacon onto high power, right? And that means it's running about 100 watts at 24 gigs, and I couldn't hear it. But unfortunately, because I'm not very good at waveguide stuff, I used a coaxial adapter to a low noise tuner preamp, but went back to coax again afterwards. I really need to. I've just acquired a 24 gigs relay from Roger, which hopefully might give me the capability of getting low noise off the 24 gigs as well. So, if I can receive on 24 gigs, I'll be very happy, because to be able to transmit it, I need about 10 watts. But I can't. You know, it's going to be very expensive to get 10 watts at 24 gigs. I've got 2 watts, so I might be able to work some of the bigger stations, but certainly we'll keep. I think that John BAL is working on 24 gigs at the moment. He's got 40 watt twit, but he's having trouble getting a changeover relay to handle that sort of power. But I've had a go.
Did you try varying the polarisation at all?
I've tried it cross-polarised when I've forgotten to adjust it back, and it doesn't work. I think there is a slight variation, again, depending on where the moon is, to what the polarisation is, but I think it's 26 dBs for a full 90 degrees, and it takes quite, it's quite a bit. There probably is a little bit to be saved, but again, it varies depending on where the moon is as well, you see. So. Right. Any more for any more?
How much of the moon are you illuminating with your beam?
The dish has got a 1.5 degree beam width.
How much does that relate to the moon?
Half a degree to
Well,
the
that's a whole.
The moon is
the
half a
moon
degree,
dissects at 0.5 of a degree, I believe. So, but the rotator I had was 1 degree.
Yeah.
But my program, the software program, only used to update that when it saw a 1 degree movement. By that time, it had moved out of the dish and on the other way.
Yeah.
So it was on its way down. You could see it was on its way down, and what I would do was manually correct it. I've now gone to 0.2 of dB by changing the sensors to some HR things which count. Which, when I first got it and put it all in, it worked fine, marvellously for 3 weeks. And then my landlord came along and cut the grass and it stopped working. Scratched my head. Spoke to Spid, they sent me over a new unit and everything, put that on, worked fine, lovely. 3 weeks, he cut the lawn again, stopped working. So I think something's blowing up one of the ICs. Since then, I've grounded the cables at both ends. I've changed one of the ICs and got one bit working again. But I'm having to manually track it for ASIUM at the moment. The elevation's working fine, but the ASIUM is not too difficult to do. Receiving, I use the 705 to listen to the beacon and then listen to one of the other stations, whoever's coming up. But what I've got to remember to do is to disconnect the 705 before I go to transmit on 2 meters. I haven't blown anything up yet, so. But for the last 4 contacts, I've been using the ASIUM manually. I've now got a scope I can put on and hopefully find out what's going wrong. It's just, there's a little emitter follower or something after the pulses, and I've got a pulse going up and a pulse coming down, and I'm only seeing 1 pulse at the other end, so one of the gates isn't working properly, so I've just got to find out why. Right, I think I'm done then.
Thank you, Will.
Okay, thank you. The actual unit I use is here, so thank you very much, young man.
Thank you very much for coming. I hope to see you all next year.
I look forward to that as well. Thank you very much. Thank you for the offer. Yeah, so that's the SSPA. So I think I paid £400 for it. Buy the same thing from Kuno. £200,000. There's a fan there. This is just to 8 gear. That moves the air that way. That's the low noise preamp. 26 gig changeover relay. Something like about. I'm still going to get 12 volts out of